Good morning, everybody. Welcome to the webinar series here at the Range Cattle Research and Education Center. I'm José Luiz. I have been working with Dr. Sellers over the past 4 years on smutgrass management. We focus on integrated management strategies, and today I'm going to be presenting part of that research that we have done. So for today, that's what I have planned for today's presentation. We are going to start talking a little bit about Smutgrass Background, and then we are going to go over why is it such a problematic weed, as well as why effective management has been difficult to achieve. Finally, we're going to be presenting the results of 2 out of the 6 main studies that we did, which both investigated the effects of simulated and natural rainfall on giant smutgrass management with Hexazinone. So weeds are as problematic in pastures as they are at any other different cropping system. So estimates are that losses due to weed competition and interference are around $2 billion per year here in the US, which makes weeds the #1 pest of livestock producers. In addition, approximately 45% of all the weeds commonly found in pastures, they are invasive, and it is also estimated that around 900 different species have been introduced here in Florida and are now very problematic invasive weeds in many different cropping systems. Here in the slide we have just a few examples. On the right we have Cogon grass and tropical soda apple. Cogon grass, it is not just a very problematic weed in Florida, but in the entire world. And on the left side we have smutgrass. So Smutgrass is a member of the Sporobolus genus, which consists of a diverse range of perennial, annual, and creeping species. There are approximately 100 different species, and they are commonly found in the warmer areas of the world. However, many of them have spread and are out of their center of origin and are now considered very problematic agronomic and environmental issue. And a few examples of places where they are problematic are Australia, United States, and Brazil. Here in the US, they are commonly found in planted grass pastures, roadsides, and disturbed waste places. And even though there are 21 different species within this genus, only 2 are considered problematic, and they are invasive, which are small smutgrass and giant smutgrass. So here we have both. On the left side we have small smutgrass, whereas on the right side we have the giant one. So as the name suggests, the size is basically the main difference between them, as well as some difference in the seed head. So giant smutgrass is a bigger plant, both diameter and height-wise. And looking at the seed heads, which is probably one of the easiest ways to differentiate them, giant smutgrass has a much more open and branched seed head type, whereas small smutgrass has a much more clustered seed head. Smutgrass can be found in 23 different states in the US, whereas giant smutgrass so far has been more commonly found in Florida, some parts of Georgia, and Puerto Rico. So that's basically what we have been going through so far. What is smutgrass? But now we are going to go through why. Why is it such a problematic weed? First of all, it is an invasive, so it can successfully establish, become naturalized, and spread to new areas without any assistance from humans. And also, it is classified, both small and giant, as a category 1 in the list of nuisance plants. So basically that means that they are increasing and spreading, increasing in number and spreading, and causing both agronomic and ecological harm. Secondly, because they decrease forage production potential. Research has shown that medium and high infestations decrease Bahiagrass monthly herbage mass by as much as 51 to 87%, which corresponded to losses around $25 to $50 per acre. And finally, the presence of smutgrass in your pasture increases the grazing pressure on the desirable species, which in turns decreases the pasture's persistence. So what happens is mudgrass usually has a very low grazing preference, so the animals tend to overgraze the other species, which at the end results in loss of persistence and herbage production. So basically, what all that information is telling us collectively is that smutgrass management is a major component of any successful forage-based livestock operation system. However, effective management has been very hard to achieve. As a matter of fact, research on smutgrass management has started back in the 50s and 60s and continues today. Many different weed control methods have been investigated, but still, effective management, especially long-term management, it is considered very challenging to achieve. So that brings up the question, why? Why is it so hard to control smutgrass effectively? There are several different reasons for that. We're going to go over a few of them today. First of all, due to its biological and ecological features. So, smutgrass basically has almost all the key attributes to be a very successful weed. For example, it can germinate and emerge throughout the entire growing season. It is a very prolific seed producer, producing as much as 45,000 seeds per plant or 1,400 seeds per panicle, which leads to a very large seed bank. And finally, it can be easily dispersed by both humans and animals. Secondly, we have a very limited amount of herbicide options available for us to effectively manage it. There are only 2 active ingredients labeled for use in pasture systems in Florida that are active on both smutgrass species, which are glyphosate and hexazinone. And both of them have some challenges to be used effectively. So for example, glyphosate is a broad-spectrum systemic herbicide, meaning that its use to manage smutgrass in, for example, Bahiagrass Pastures is restricted to broadcast applications with backpack sprayers, which are simply too labor and not feasible to be done when you have weed infestations greater than 10%. On the other hand, we have hexazinone. Hexazinone is the only selective herbicide that we can use to manage smutgrass that can be broadcast applied over the top of Bahiagrass and Bermuda grass pastures in the selective control smutgrass. However, the standard recommended rate for smutgrass management, which is 4 pints per acre, it is very expensive, probably one of the most expensive pasture treatments, turning around being in around $100 per hectare. So I would say 40, 45, 50 maximum per acre. And besides that, besides this very, very expensive cost, sometimes it results in lack of control. And the main reason for this occasional lack of control for such an expensive treatment is a result of the interaction of these 3 main factors: hexazinone chemical and physical properties, the soil properties where most of the forests are grown in Florida, and finally the rainfall pattern after application. So what happens is hexazinone is classified as a soil-applied herbicide, right? So that means that when we are attempting to manage emerged plants, most of the absorption is happening at the roots. So it is most uptaken by the roots. Okay? But due to both its chemical properties and the soil properties here in Florida, can be very, very challenging to achieve proper absorption. Hexazinone is classified as a prone to leaching herbicide because it has a very high solubility and low coefficient of adsorption. And, like I said, the soils where most of the forests are grown in Florida, they are very sandy with low content of organic matter. So, what that results is that we need a herbicide that needs to be present at the root zone, to be mainly uptaken by the plants. However, due to its chemical properties and the soil properties, it's very easy to be leached out of that root zone. And sometimes we won't have the amount of herbicide that we need at that specific area to provide effective kill. So in other words, there are a couple of scenarios that might be happening in the field. Let's simulate some of them here. So let's say that we have our pasture, we're infested with smutgrass, and we decided to control it applying Hexazinone. So we went out there, we applied, and let's say for this first scenario that we didn't have any rainfall after application. So what happens is most of the herbicide will stay either on the leaves where it hit, or most likely most of the herbicide will stay at the soil surface. And that's a problem, right? Because I said that it is mainly uptaken by the roots. So usually when that happens is that we do have some symptoms, because even though Hexazinone is not very effectively translocated, it is translocated to the xylem, so we will see some foliar injury, but that's not enough to control a perennial, warm season, tough weed such as giant smutgrass. So most of the times when we spray and we don't have any rainfall after application, we will be seeing something like this. Some injury, but not enough to provide effective kill. So our second scenario here is now we sprayed, and let's say that we had the ideal amount of rainfall after application. I mean ideal because it was just enough to keep the herbicide within that root zone. And most of the times we would see something like this, which is a very, very effective control. In our third scenario, third option would be after spraying, after application, we had too much rainfall, which provided leaching to below the root zone. And again, we might be seeing some symptoms, some injury. However, it is just not enough to provide effective control of such tough weed such as giant smutgrass. So even though Hexazinone leaching has been extensively studied in the literature, most of the times using soil columns experiments in the greenhouse, there is very little information, to none actually, regarding what is the ideal amount of rainfall that we need to have after application when we are trying to control giant smutgrass here in Florida pastures. So basically, it is still necessary to first develop new management strategies to effectively control giant smutgrass, and also to optimize the use of Hexazinone, because it's a very expensive herbicide and is our only selective option. And one way to do it is by better understanding how rainfall affects its efficacy. So the first topic was the goal of most of the experiments that I did here with Dr. Sellers, but because they have already been presented in previous presentations, and actually one of them is going to be presenting tomorrow at a field day that we are having. Today I'm going to focus on this other objective, which was to better understand how can we enhance or optimize the use of Hexazinone by better understanding how rainfall impacts its efficacy. So even though Hexazinone use by itself should not be recommended when you are trying to manage giant smutgrass, because we always need to think about integrated management strategies, herbicides in general, they still play a very important role at any integrated weed management. So it's very important to understand ways that we can better use our only selective option. So let's start talking about our rainfall experiments. Let's start talking about the experiments that we did in the greenhouse. The objectives were to determine the effects of increasing simulated rainfall volumes on Hexazinone activity at two different rates, 2 and 4 pints per acre. And we hypothesized that lack or excessive amounts of rainfall will decrease hexazone activity. And that was our goal. What is lacking? What is excessive? So the main goal of this research in the greenhouse was to determine what is the optimal amount of rainfall that we need to have after hexazone application so that we can have a maximum hexazone performance. So the experiments were conducted at the greenhouse here at the center 3 times, 1 time in 2017 and 2 times in 2018. The pots were filled with soil, collected here at the station, and the plants were allowed to grow in the greenhouse for approximately 2.5 months before we actually start the experiment, spraying the herbicides. So the treatments included the 2x7 factorial arrangement of 2 hexazone rates, 2 and 4 pints per acre, and 7 simulated rainfall volumes, ranging from 0 to 8 inches. So that's how we did the herbicide application. The herbicides were applied with a CO2 pressurized backpack sprayer, calibrated to deliver around 20 gallons per acre. And then, approximately 1 hour after herbicide applications, the pots were submitted to the different simulated rainfall volumes. So, just illustrating for you on the picture on the top, it's a picture from the inside of the rainfall simulator. And the picture on the bottom, it's after simulating the rainfall. We let the pots dry for approximately 3 hours before returning them to the greenhouse. And after all the re-irrigation that we did after simulating the rainfalls, they were done by sub-irrigation to avoid confounding effects with the rainfall treatments. We had 2 response variables, the visual percentage of control at 30 days after treatment and the biomass reduction at 30 days after treatment as well. And today I'm going to present the results regarding only the biomass data. So because we had a rainfall by hexazone rate interaction, we had to construct 2 separate curves, one for hexazone at 2 pints per acre, which is here showed by the solid line, and another for hexazone at 4 pints per acre, the other dotted line. So here on the x-axis we have our increase in simulated rainfall volume, and on the y-axis we have our response variable, which is dry biomass reduction. So let's start looking at first the results that we had for hexazone at 2 pints per acre. So basically what we saw is that hexazone activity was increased when it received anywhere from 0.25 inches up to 1 inch after irrigation. So when we had 0.25, half, and 1 inch of simulated rainfall after application, we had a greater dry biomass reduction compared to, for example, no rainfall at all or any rainfall amount greater than 1 inch. Here's just a picture illustrating what I just said. We can see that the pots that received 0.25 up to 1 inch of rainfall exhibited very good hexazone activity, whereas all the other rainfall treatments they did not work very well. So now let's go over the results for hexazone at 4 pints per acre, and similar to the other rate, we had better results in a specific range of rainfall after application. However, the range for this one was a little bit bigger. So for hexazone at 4 pints per acre, hexazone peak of activity occurred when we had 0.25 up to 2 inches of simulated rainfall after application. So when we did not have any rainfall at all, and when we had rainfall amounts greater than 2 inches, we had decreased hexazone activity. Another picture showing us this, and differently than the other picture here, the pots that received 2 inches, they also are showing good symptoms and good control. So basically, our conclusions for the greenhouse experiments are: rainfall after application did impact hexazinone activity, regardless of the rate, and hexazinone peak of activity appears to occur from 0.25 to 1 inch of rainfall after application for hexazinone at 2 pints per acre, and when we have 0.25 up to 2 inches of rainfall after hexazinone at 4 pints per acre, after application of hexazinone at this rate. So that was very interesting, but we also would like to, we also had this question: what about natural rainfall effects in the field? So we also tried to determine what are the impacts of natural rainfall on hexazinone activity when attempting to manage giant smutgrass. So we did a field experiments in 2017 and 2018. Here in a neighboring property here close to the Range Cattle Research and Education Center. And at both locations, at the beginning of the experiment, we installed a rainfall data logger at the experimental sites, which basically recorded the amount of rainfall every hour from the beginning until the end of the experiment. So basically what we did was, starting on the first week of May in both years, we started doing weekly applications. So every Friday, starting on the first week of May, I would go out there and apply hexazinone in a field that was highly infested with giant smutgrass at both rates, 2 and 4 pints per acre. And I did that for 22 weeks in a row. So the first week of May until the last week of September. And then 35 days after application, we returned to the plot and we did visual estimates of control. And we also did percentage of density reduction by counting the number of live clumps approximately 6 to 10 months after application. And today we're going to be presenting the results only of the percentage of density reduction data. So what we did was, after we collect all this data, we designated a rainfall class for each plot. So because we had our rainfall data loggers installed at the field sites, we had the total amount of rainfall that each weekly application received 7 days after application. So for each one of those 22 different weekly applications, we had a specific amount, we had recorded the specific amount of rainfall that happened 7 days after application, right? And then we did some statistical analysis to compare the level of control, analyzing both the effects of rate, the effects of application time, and the effects of those rainfall classes that we designated to each application time. So because we had a rainfall class by hexazinone and rate interaction, results were presented separated for each hexazinone rate. So let's start talking about hexazinone at 2 pints per acre. And basically what we found was that greater density reductions were recorded when we had 0.35 up to 3 inches of rainfall after application, which are the rainfall classes 1 to 3. And then for hexazinone and 4 pints per acre, although rainfall classes 1, 2, 3, they also showed the graded average means, the greatest numbers, the results, there was a lot of variability, and we didn't detect a lot of significant difference among treatments. And the reason for that is because even though we detect that there is an effect of rainfall, even for the field experiments on hexazinone activity for giant smutgrass control after application, there are still many other different factors that can impact the efficacy. And one of them, or maybe a few of them, are the timing that the first rainfall happens, let's say after application, within those 7 days period, when is the first rainfall event happening, and also the intensity of that first rainfall event. So here we have a good example that illustrates that. On the picture on the left, we sprayed the Hexazinone 4 pints per acre on the second week of August, and the total amount of rainfall that we had during the first 7 days after application was 4.1 inches. And we had a very good control. Maybe it's not very easy to see in the picture because we have a lot of other weeds growing on the plots, but around 91% of all the clumps, Smutgrass clumps present, they were dead. And then just one on the picture on the right, just 1 week after that, we had 3.3 inches of rainfall during the first 7 days after treatment, and we actually had very poor control, only 49% of density reduction. And the main difference here is the time and the intensity of the rainfall events at each situation. So for example, for the picture on the left, even though we had 4.1 inches, we had very small amounts, and a little bit, we had 1 inch of rainfall the first day after application, and then we had 0.6 inches on the fourth day. So we didn't have a lot of rainfall at once, and we also didn't stay a long period of time without any rainfall. So that was very beneficial. On the other hand, for the picture on the right, we didn't have any rainfall at all up until the fourth day after application, when we had only 0.6 inches. And then we had a very big amount at the day number 7, which was 2.4. So not only the amount of rainfall after application is important, but the application timing, and also how is this rainfall happening. Is it everything at once, in 1 day? Is it spread in a couple of days? So that still requires more research to be fully understood. So finally, just to wrap up this presentation for today, we conclude that giant smutgrass management with Hexazinone should continue to be performed with 4 pints per acre because it provided much greater and consistent results throughout both of the experiments in both years. And the dynamic mobility of Hexazinone in the sand soils where most of the forests are grown in Florida may explain why sometimes we have effective and why sometimes we have lack of control. Also, peak of activity appears to occur when followed by 0.35 up to 3 inches of rainfall during the first 7 days after application. However, as we were just saying, there are many other factors that can still impact the efficacy of control, so there is no such thing as a guaranteed recommendation. However, we should always try to maximize the likelihood of success or maximize the chances of success of our application. So instead of applying Hexazinone, let's say during mid-July, regardless of the rainfall forecast, would be beneficial if you could check the rain forecast for the day of application, the following one day or two, and then only apply it if they meet the requirements that at least 0.35 inches and no more than 3 inches of rainfall. Finally, I would like to say that Hexazinone should not be used as a single control tool. Rather, Hexazinone should be viewed as one extra weed control tool in the toolbox for giant smutgrass management. So integrated management is the key. Future research should be conducted over longer periods and more locations so we could have a better understanding of the actual impacts of rainfall on Hexazinone activity as well as giant smutgrass management. So with that, I would like to thank my major advisor, Dr. Sellers, first of all for receiving me and giving me the opportunity to come here to the US to do my PhD. I would like to thank all the members of my committee, Dr. Farrell, Inlow, Vendramini, and Muriel, as well as all the institutions that provided funds for all my research, USDA and Florida Academy Enhancement Board. And finally, I would like to thank everybody that helped me throughout these 4 years, which were a bunch of students from Brazil and here from the US. Thank you very much.